Hello everyone, today we're going to do the lab called single replacement. Now the purpose of this lab is to investigate the activity of metals using an online simulation, which we have over here on the right. It is a flash file, so we can't do it on our iPads any longer. Now what is this going to look like? What the simulation involves is a number of reactions. So what we have first here are some beakers that contain solutions, and it's labeled what the solutions are. And then we have some pieces of metal, in this case magnesium, and we can change what those are. We dip it into the solution, let it sit for a minute, and pull them back out of the solution. Now, what does that actually look like? Now, in the real world, it would probably look something like this. What we have here is a solution of silver nitrate. All right, a silver nitrate solution. And a silver nitrate solution is pretty much just clear. You really can't tell there's anything dissolved in that liquid. It's a solution. And then we have a piece of metal, copper in this case. Now, in the simulation, what they do is they take the piece of metal and they dip it into the beaker. So if I dip this copper into the beaker and let it sit for a minute or two, a reaction might start happening. If I pull it out, I can see that there's a color change and some kind of reaction has happened. Now, in this case, what happens is that the copper will replace the silver nitrate in the solution, and the darkness that you see on the piece of copper here is silver starting to form on the copper plate or on the copper piece of metal. If they left it in there a very long time, it would be similar to the one reaction we looked at where they had the copper tree and they put a solution of silver nitrate in it, and it starts to form silver on the surface of the copper. So in the simulation, that's what's actually happening. Now, this dark stuff that's on the copper is actually silver. All right, that's some silver that's accumulating on the copper. Little tiny crystals of it. All right, let's start over and do some data collection here. All right, we have 3 different data tables that we're going to try to fill in by watching the simulation. All right, let's start the simulation once again. What we have is a number of beakers that have solutions in them, and then we have different metals that we're going to dip into those solutions, and we're going to start off with magnesium. We dip them each into the solution, wait for a second or two, pull them out, and look at what has happened. Now, in the first one, the piece of metal really didn't change at all. In the second, third, and fourth one, something did happen. All right, now, what are we going to write down in our data table for this? All right, for the first row, we're using magnesium metal. So all of these pieces of metal here were magnesium. And then we have the 3 solutions. So on the chart, the row represents taking magnesium solid metal and putting it into a solution that contains these ions. And they're all nitrate solutions. Magnesium nitrate, zinc nitrate, etc. Now, in the first beaker, nothing happened. So we're going to write, let's put an X there, meaning that no reaction happened. And then in the second, third, and fourth one, something did happen. So we're going to say yes. All right, what does this mean? That means that magnesium does not do anything when you put it into magnesium nitrate. But it does a reaction when you put the magnesium into zinc, copper, or silver nitrate. All right, so that's data for the first row. Okay, let's continue the simulation. Next, we pick copper. We dip each piece into the beaker for a minute or two, pull them back out, and see what kind of data we're going to collect here. All right, the first column and the second column, I'm going to put an X there, put an X because nothing happened. In all first 3 columns, nothing happened. The last one is going to say yes, a reaction did happen. All right, let's continue. Next, we will pick zinc. All right, choosing zinc metal, We shall dip them into the beakers and wait for a second and see what happens. Pull them back out, and here's what we get. Here, we're going to write down nothing, no reaction. In the third one, yes. In the fourth one, also yes. All right, let's do the next element, silver. So we pick silver. We dip each one of them into the solutions. Wait for a second. Pull them back out and see what happened. Now, in this case, it looks like none of them did anything. So for data, in this case, we'll just put X's all the way across. Nothing happened in all 4 beakers. Alrighty. Now, the next thing we got to do then is put these metals in order of increasing activity or decreasing activity from the most reactive to the least reactive on there. Now, which one of these metals is the most reactive? Well, magnesium had 3 out of 4 of them react, so we might put that first. So let's put magnesium at the top of our list. All right, Mg. The least reactive one was silver. It didn't react at all, so let's put that on the bottom. Now, which should come first, copper or zinc? Zinc had 2 reactions out of 4, so we'll put it second, and copper had 1 reaction out of 4. So there's our order. So this is a list of the activity from most reactive to least reactive for these particular 4 metals: magnesium, copper, zinc, and silver. Next then, we're going to do the same thing with different elements. All right, the same thing with different elements. So back to the reaction. Let's let it run here. In this case now, we have 4 new metals: iron, lead, nickel, and tin. So we'll start with iron, dip them in, and see what happens. In this case then, for the iron row, the first reaction was nothing. We'll say X. And then the next 3 were yeses. We'll just say yes. They all did react. So iron can replace lead, it can replace nickel, it can replace tin. So it should be higher up than those other 3. All right, continuing on, next with the element lead, or Pb. Take a piece of lead, dip each of them into the solution, and then we pull them out and see what happened. Now in this case, it looks like nothing happened in all 4 cases, so we'll put X's all the way across. All right, lead is quite non-reactive. All right, let's switch up the metal again, this time picking nickel, Ni. Dip each of them into the solution and wait for a second, pull them out, and take a look at what has happened in this case. The first one, no reaction. We'll put X. In the second one, yes. In the third one, no. And in the fourth one, yes. So we get 2 out of the 4 react. All right, switch up the metal again to tin, Sn. Dip a piece of those into each beaker. Wait for a second, and then pull them out to record some data. And we have the first one, no reaction. The second one, a yes. The third one, no reaction. The fourth one, no reaction. Now, we can make a list of these. Make a list of these in the order from most reactive. Now, on this list then, I'm going to put iron first, Fe, most reactive. I'm going to put Pb last because it's the least reactive. And then I want to put nickel underneath iron. It got 2 out of the 4. And then Sn, tin,
which only had one of the four. All right, so now we have two lists. We have two lists, and the next thing to do would be to combine these two lists together. To do that, we got to figure out how the second list relates to the first or the first to the second. We may need to do some additional experiments to do that. So next, what we'll do then is more reactions with different metals. Now we're going to group together, sort of mix them together, and then come up with the master list of all 8 of them at the same time. All right, so we're going to go to activity number 3 and do the same thing. All right, activity number 3 then has kind of a 2 from the first group and a couple from the second group. And then we're going to do the same thing. First, we'll start with Fe for a metal, dip it in, pull it out, and then see what reaction has occurred. All right, the first one then, Fe in iron nitrate has no reaction. Second one, no reaction, and then yes and yes. Yes and yes. All right, the next element will be copper. So we are going to pick copper and dip it into the solution. And to see what happens, pull them out and record our observations. Now, what's going on here? In this case, it looks like nothing happened all the way across. No reaction for each of them. All right, let's switch up the metal now to zinc, Zn. Dip them in, bring them out, and see what happened. In this case, the first one is a yes, and then no reaction, yes, and yes. And then one more. We're going to pick the element lead, dip them in, wait for a second, pull them out, and it looks like no reaction, yes, and no reaction. Next then, we want to try to combine both lists into one big list. All right, let's take a look at it. Now, magnesium got 3 yeses, iron got 3 yeses, and zinc all got 3 yeses. So those 3, one of them is probably going to be at the top of the list. All right, magnesium, iron, and zinc. All right, now, in the first group, we had magnesium and zinc, so we know that magnesium should be above zinc. In the second list, should iron become above magnesium, or should it come above zinc? If we look in the third list, iron should be below zinc. All right, iron should be below zinc, and zinc is below magnesium. So we now know that we should have magnesium, zinc, and then iron. Those are the 3 most reactive, and we know, whoops, that should be Mg, magnesium, zinc, and iron. All right, so we know those are the top 3, and then the least reactive one, probably on the bottom, looks like that's going to probably be silver. So we can put that one way down at the bottom. And now we got to figure out the rest. What do we have left then? We also have now left nickel, tin, lead, as well as copper. All right, as well as copper from the first list. Now, where should we put them? You got to fit in here somewhere. Next, let's consider copper. Where should copper go? Now, copper on the first activity should be below everything except for silver. So we know copper should be above silver. But how about the other elements? So in activity number 2, no copper. Activity number 3, copper should be below everything that's on that list. It should be below iron, it should be below zinc, it should be below lead. All right, so lead should be above it. All right, how about lead? Where should it go? Lead is in activity number 2, and it had X's, so it should be below iron, nickel, and tin. All right, so we know that iron, nickel, and tin have to be above lead, and copper has to be above silver. All right, so are these 3 in the correct order? Should nickel be below iron? Activity number 2 says that nickel should be below iron, and we know nickel, tin, and lead are in fact in the correct order with each other. Therefore, those 3 should be below iron, So nickel is below iron, tin's below iron, and lead's below iron, and copper should be below lead, and therefore we have our list. Magnesium, zinc, iron, nickel, tin, lead, copper, then silver. We have one more activity to go. Activity number 4. All right, let's see what that entails. Here, the only additional thing that we're going to add to it are an activity with hydrogen. All right, in this case, the solution is HCl, hydrochloric acid. So we're going to do an activity where we dip each of the metals into that and see what happens. First, we'll start with silver, and if it reacts, then silver can replace H in HCl. All right, nothing happened there, so we'll say X. Next, we have copper. Copper is dipped into hydrochloric acid, and when we lift it out, we see that it is unchanged. So copper cannot replace hydrogen in hydrochloric acid. All right, next we have nickel. Skipping down to nickel, and some bubbles are happening here. And when we pull that out, nickel will have reacted with hydrochloric acid. So something did happen. PB, we'll put that into there, and again, bubbles. So we're going to say that, yes, a reaction can happen. All right, now, in this case, it's hydrogen gas, so they don't stick to the metal, they just float away. All right, one last one, tin, SN. Put that into the acid, and bubbles again. So those react. All right, those are the only ones that we have. All right, can we figure out what our order is from that? Now, what has to happen here is that we're going to take the blue list and add to it one element, hydrogen. Where should it go? Now, we know that silver and copper do not react with hydrogen, so they'll be on the bottom of the list. And from the blue list, we know what order they should be in. So we're going to have copper as number 8 and silver as number 9. Hydrogen will be above it. Now, the rest of these. We have no data here on this chart for the elements iron, magnesium, and zinc. Now, relative to each other, how should they go? According to the blue list here, iron, magnesium, and zinc should be magnesium, zinc, iron. That's the order relative to each other. All right, so then on activity number 4, we've got nickel, lead, and tin. All right, nickel, lead, and tin, and those should be in the order of nickel, tin, and then lead, in that order relative to each other. All right, now from the blue list here, we know that nickel should be below iron, so as a group, these are in the correct order. Now the question is, should hydrogen be above or below them? From activity number 4, we can see that hydrogen should be below nickel, tin, and lead. So they'll maintain that order, but we will put hydrogen below them. So hydrogen should be below them on that list, and we are done. Filling it in correctly then. Magnesium, zinc, iron, nickel, tin, and lead, and then hydrogen at number 7. All right, that is the activity series according to the data that we collected here.